or what is that? Valid C identifiers, right? So we started with this, right? So you, so here you can see, so here in the case of valid identifiers, the possibilities are the first character can be as capital letter, small letter, or underscore. So all these symbols are categorized as letters. And the next possibility is that we can have combination of, so for first position, certain constraints are given. For the rest of position, I can have a combination of alphabets, that is whether it can be a small letter or capital letter, and I can have the underscore, and then I can have digits, right? So here, and then length, with respect to the length of there is no constraint. Okay, so we have defined an expression for representative and it's the identifier. So with regard to the first part, the one among this should be there, right? So letter, and then with respect to the next part, I can have combination of letter and digit. So letter and digit, right? And then this letter and digit can be of any length. So I'm going for asterisk, right? There is clean closure of letter or digit star, right? And then I'm going to concatenate letter, right? Letter concatenated with letter or digit star, right? So here, this is represents the first part of the variable name, right? So the first part of the variable name is going to be this one, and the rest of the part of the variable name is represented by this part, right? So what is the main constraint? I should have at least one symbol in the sense that symbol should belong to the letter, variable, right? So with the rest of the part is going to be optional. So optional in the sense that's what we are going to give the clean closure. So clean closure is going to be 0 or more. That is epsilon empty is also possible. I hope already we have discussed. If suppose I need at least strings of length it is, then in that case I'll be going for positive closure. Okay. How we can represent this by means of a transition diagram? Okay, so here this is an expression how we can represent this by means of a transition diagram. So please make a note. Already we have discussed a simpler transition diagrams, right? So here we have discussed, yes, this is a simple transition diagram, right? So from the start state, I'll be there will be an initial state, initial condition, right? So from that initial condition, I'll be moving on to another state based upon a given input. Okay, so how to designate that start state? So in order to designate the start state will be having an incoming edge that comes from nowhere. Please make a note that this is an edge which comes from nowhere, whereas this is an edge. So here this on state is having an incoming edge which comes from this off state, right? Whereas here this off state is having an incoming edge which comes from nowhere, right? This is how we are going to designate a start state in transition diagram. Okay, we have to designate it, right? So this is how we will be designating it. Okay, so here if you talk of this finite state machine, we will be using circles for representing these states, right? And the transitions are represented by means of edges. So in the edges that will be on a given input only, we can have the transition. So this is the input, and then the start state is represented by an incoming edge that comes from the mover, and then it will be having a label as start. Okay, so label as start. And then your final state machine will be having a final state. So when all the conditions are over, when all the state operations are over, here you can see, right? So here we have seen, right? So here I'm having an environment editor, right? Word editor or whatever it may be. Okay, so I am in the editing stage. And in the editing stage, my document is open, so I can proceed with the typing or formatting. So I'll be in the same particular state. Then if I click this close icon, what happens? I'll be moved on to another state where I'll be given the three different options. Either I can save or I can don't save or I can cancel. So if I give the save option, my document will be closed, right? My document will be saved and closed. After that, I cannot proceed with any operation, right? So I have reached the final state. So here, this is how we will be designating the final state. Double circle represents the final state. And next is going to be next, don't say in the sense the document is not going to be saved and then it is going to be closed. Again, after that, we cannot make any changes. It is going to be the end. That's it, right? So it's designated by double circle. So here we'll be using uh, uh, the intermediate states are represented like this, right? And then start state will have an incoming edge that comes from over, and the final states are represented by double circles. And please make out whenever you are drawing a transition diagram, it should have a direction of flow. Transition direction should be mentioned. Okay, so just a straight line, what does it mean? So no meaning will be conveyed. So we have to mention the direction of transition, right? The direction of transition will be mentioned, and then from what input I'm having the transition, that should also be mentioned, right? So okay, we can see a simple example for this direct identifier. So as usual, so for example, let us consider. So let us consider uh, so is it a valid identifier? C identifier?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes, good. It is a valid C identifier. So what I have to do, I have to for a valid is equal to okay. Here please make a note. I'm not going for any declaration and all, right? So please make a note here. Here, let me proceed with designing, as you say, it is a valid C identifier. So my machine should accept the string. So because this belongs to the given language, valid C identifier language, right? So what I should do, so I'll be having a start state. So it's going to be Q1, right? Okay. So what is this? What is this? All these characters belongs to what should be the letter? Okay, so as you say, this is a valid C identifier. Then yes, S is a valid C identifier. Underscore S is a valid C identifier. All these are valid C identifiers, right? Okay. So here, if I come across letter, okay. So if I come across a letter, then what should I do? I have to move on to another state, right? I will move on to another state, right? Please make a note. After this, what is the first constraint? The first constraint is the main constraint is the first character should belong to this category. That's what we checked, right? The main constraint is this. After that, what I can have? What is the what about what I can have? Yes, please.
You can have both letters and digits after that.
Yes, let us consider this one, right? Okay. So here, yes, this is satisfied. So I'm moving on to Q2, right? I'm moving on to Q2. So after that, if I see a T, it will be accepted. After I see a U, it will be accepted. And after I see a 0, it will be accepted. After I see a 1, it will be accepted, right? So for each and everything, I cannot go for a new state. Okay. Instead, I'll be so because there is no change in condition. After this, whatever character comes, only thing is that it should either belong to letter or digit. That's it. right? So if any other character comes, I have to take some other decision. But till I reach letter or digit, I'll be in the same state. And then it can be of any number of times, right? So here I can get letter any number of times. So I'll be having letter any number of times, and similarly I can get digit any number of times. So here you can see, okay. So so here I am in Q2. In Q2 I am seeing a 1. Yes, okay. It got accepted. So I am in Q2. In Q2 I am seeing in equal to. What does it mean? What does it mean? The variable. So is it a variable name? Does it belong to a variable name? No. No. So what I should do? My pointer should track back to the previous position. So this is going to be the variable name, right? So this is the variable name. So what I will do is that if any other character or symbol comes, I'll be moving on to the final state where I will be backtracking. Okay, so please make a note here. After this is not a valid identifier, I will reach the final state. After this point, I will not proceed with the scanning process. Instead, I will be stopping the iteration and then I will be tracking back my pointer to the previous position. That is what we are designating here, right? So that is what we are designated here. So asterisk is nothing but backtracking to the previous state. Okay, backtracking is previous state. So if suppose a blank symbol, whatever may be the case, whatever we see other than letter or digit, I'll be moving on to the another state. Let me call this as Q3, but I should backtrack to the previous state. So here, so previous state in the sense my pointer will be in this position. So SQ 01 will be considered as a valid C identifier, right? So here you can see, yes, letter or digit. So that's it. Either yes, I have given like this, right? So here this is also goes good, or else you can proceed in that way. Right, letter or digit, I'll be in the same state Q1. If any other character comes, I'll be moving on to final state Q2, where I will be proceeding with backtracking. Right. So this is with respect to valid C identifiers. What if uh, what, what about the keywords? So here you can see then is a keyword, right? Then is a keyword. So for then is a keyword, want is a keyword. Likewise, it goes on. So many keywords are there. Int is a keyword, float is a keyword, right? So here you can see it is going to be, I can have any possibility of combinations, right? I can have any possibility of combination. So I'm going for a generic representation. Okay. Whereas in this case of keywords, I'll be explicitly mentioning. That's it. Okay. I'll be going for explicit mentioning, right? So here, if I see a T and move on to another state, H move on to another state, E move on to another state, N move on to another state, right? So if it is going to be a non-letter or digit, then I'll be reaching the final state and then I'll be backtrack to the previous position. Okay, I'll be backtrack to the previous position. So for with respect to the keywords, the exact keyword will be given, for example, void. So in the sense, V, O, I, D. Right. So if I come across any other non-letters or digit, then I have to proceed with uh, reach the final state and then I have to proceed with backtracking. So this is with respect to the keywords. Please make a note. I'm just giving you an overview, right? So it will be clear for you when we see more and more examples. Just overview we are dealing with. Further examples we will be dealing with. Okay. So here we will be discussing with regard to the relational operator. So here, what is a relational operator? So here you can see relational operators in the sense I can have less than or equal to, less than or greater than, right? Or just less than. And then next comes I can have equal to, greater than, equal to, or greater than, right? Okay, so here please make a note. Consider a programming language which has the relational operators like this, right? So here by convention we go for double equal to, right? So here a specific programming language uses this type of relational operators, right? So here please make a note. A combination of two operators gives you meaning. Okay, combination of two operators gives you meaning. These are not different operators, together gives you meaning. Okay, so this is less than or equal to, this is not equal to, and this is less than, this is equal, this is greater than or equal, and this is greater. Okay, so please make a note over here. That's what we are dealing now. So for example, a less than or equal to b, right? So this is a variable and this is a variable. Leave that. Okay, so here we are designing the relational now, what is it? Transition diagram for identifying the relational operators. Okay, I am in start state. Okay, so this is a start state. Let me call this as Q naught. In Q naught, I'm coming across less than. Okay, in Q naught, coming across less than. So here in the case of relational operator, so please make a note over here. In the previous case, you can see I cannot restrict whatever may be the number of terms coming here. Okay, so the length will be infinite. Okay, whereas here, with respect to the relational operator, you can very well say only two character combinations are possible, two operator combinations are possible, right? So I'll be going for scanning only for two operators, not more than that. Okay, so here you can see, yes, you can see I can have this option, I can have this option, right? So what is the thing? Please make a note here. Q naught, in Q naught, I'm seeing the less than operator. Once seeing the operator, I cannot take any decisions. If suppose I am taking a decision, what I will conclude as less than. But what is a possibility? There is a possibility if suppose this operator comes, then it conveys the meaning of not equal to. If suppose this operator comes, it conveys the meaning of less than or equal to. So what should I do? I have to move my pointer to the next position. That's what we are dealing with. So what I'm doing, so if I see a less than, I will move on to the another state, that is Q1, right? Q1. Okay. Okay, moving on to state Q1. In Q1, if I suppose C equal to symbol, right? So what is the meaning? It means that it is less than or equal to. I may not move on to the next position. That is not required at all, right? Because there is only possibility of less than or equal to, not equal to, right? So further scanning is not required. So I can make the decision now. So what is the meaning? So it is going to be, I can reach the final state and then I can say it is less than or equal to. That's what we done here. We have reached the final state. This is nothing but equal to, right? I have reached the final state and then it is returned less than or equal to. And if suppose in Q1, if I see a greater than symbol, if I see a greater than symbol, so what I should do, I have to reach the final state and then I have to say it is not equal to. Okay, if suppose it is going to be any other symbol, so it is not equal to, it is not greater than. If suppose it is any other than that, okay, please make note. I'm checking only whether it is equal to or greater than. If it does not belong to this category, if I come across any other thing, then what I should do, I have to move my pointer to the previous position. So that's what we done here. Okay, so I have to move my operator, pointer to the previous position, and then I have to reach the final state, and then I have to come to the conclusion it is less than. Is that clear for you? Are you clear with this? Yes, ma'am. Yes. Okay. So this is with respect to the less than operators, right? Less than operator. And then equal to operator, that is only one possibility equal to. So in Q naught, so here, okay, so here this is this equal to with respect to the relational operation, right? So if I see an equal to operator in Q naught, what is the conclusion I can reach to the final state, and then I can return equal to, right? Suppose I am coming across greater than operator. So what will be the possibility I can have? A greater than or equal to B, A greater than B. So these are the two possibilities. So in Q naught, I can see greater than, but on seeing greater than, I cannot come to a conclusion. Okay, so come to a conclusion. So I have to move my pointer to the next position. Only based on the next character, I can next symbol, I can make any decision. Right. So if suppose after greater than I come across, so here in Q naught, I am seeing the greater than. So what I should do, I have to move my pointer to the next position, and then I have to change my state. Okay, change my state. Okay, so in Q1, I am seeing an equal to operator. I'm seeing an equal to operator. What is the meaning? The meaning is it is less than or equal to, less than, sorry, it is greater than or to, right? So I can what is that? I can reach the final state, and then I can return greater than or equal to. Okay, that's what. So if it is equal to, reach the final state and then return greater than or equal to. Here, what is the next possibility? So here I'm not getting equal to, instead I'm having some other symbol. I'm having some other symbol. So what should I do? I have to reach the final state, but I have to move my pointer to the previous position. Move my pointer to the previous position, right? Please make a note why I have come to the previous position. So here, this doesn't belong to this operator at all, right? Okay, so here I have to proceed further with the scanning process. So I have to backtrack to the previous position, and then I'm going to return greater than. Okay. Yes. Okay. Now we can move on with some simpler examples for designing the finite automata. Okay. So here we can start with. So what is the target? Finite automata accepting the language of strings ending with AA. Right? Strings ending with AA. So please make a note. So whenever we are designing an automata, so we have to design the automata for the basic level. Okay. So what does it mean? Finite automata accepting the language of strings ending with AA. So first we have to understand the language. How to understand the language? First we have to list out all the possible strings that belong to the language. Okay. Not all. Some of the possible strings that belong to the language. Okay. So because it is an infinite language, right? So I have to list out some of the possible strings that belong to the language. Okay. So here I have to design an automata which accepts all the combination of strings that belong to this particular language. So which is the minimum string possible? So ending with A in this is ending with A in the sense A is possible. Then I can have any number of A's. I can have BAA, then ABAA. Yes, that's what ABABAA, AAABAA, likewise it goes on, right? So minimum string possible is AA. So I have to design a finite automata which accepts this. So what should I do? I should have a start state. Okay, I should have a start state. Let me call this as Q0. On seeing an input, I have to move on to the next state. Let me call this as Q1. Please make a note, I am not designing a finite automata in a generalized fashion. I am designing a finite automata to accept AA. That's it. Okay. So here, you please make a note now. Till this point, we have discussed regarding backtracking, right? So while designing the finite automata, we are not used. So that is a usual that is your pointer will backtrack. But while designing the finite automata, we will not consider backtracking. Okay. So here please make a note. I'm going to so here please make a note. So I am in initial state Q0. In Q0 I am seeing an A. Yes, in Q0 I am seeing an A. What I will do, I will be moving on to state Q1. Okay, in Q1 I am seeing an A. So what I will do, I will move on to state Q2, which is the final state. So what do you mean by acceptance? When we will say a string is accepted, so on the given input string, I should be able to start from the initial state and I should be able to reach the final state. Please make a note over here. A string is said to be accepted by a finite automata only if it is able to start from the start state and able to reach the final state on the given input. Okay, so here on the given input I was able to start from the start state and reach the final state. Okay, so here next one. So my finite automata, now I am going to update my finite automata to accept this. Okay, so here you can see, so this is Q0. In Q0, I am seeing an input symbol A. Where will be my transition? Where will be my transition?
Q1.
Yes, good. I'll be having a transition to Q1, right? I'll be moving on to Q1, right? In Q1, I am seeing an input symbol A. So where will be my transition? In Q1, I am seeing an A. Q2, Q2. In Q2, I am seeing an E. Where should be my transition? Please make a note over here. I should have two A's at the end. That's it, right? So whatever may be the number of A's comes after that, where should be my transition? Can I reach the final state or not? Is it a valid string or not? A.
Yes.
Yes, then where should be my transition? Please make a note.
Again,
Yes, good. My Turing machine should accept, sorry, my finite automata should accept this, should accept this, should accept this. Likewise, it goes on, right? It should be in the same state. Okay, same state, right? So the next possibility is BAA. So BAA, is it a valid string? Is it a valid string or not?
yes.
Yes, it is a valid string. Is this a valid string? Whatever may be the number of B counts, it is a valid string, right? So where should be, so let us consider this one, right? So I am in state Q0. In Q0, I am coming across B. Where should be my transition?
Q0.
Yes, very good. I should have the transition to Q0, right? So as you say, I'm in state Q0 and coming across B, I'll be having transition to Q0 again. In Q0 and coming across B, I'll be having transition to Q0 again. In Q0 and coming across A, I'll be moving on to Q1. In Q1, I am coming across A, I'll be reaching Q2, which is the final state. Very good. Okay. Next, please make a note. So this tree. A, B, A, B, A, right? So I am in state Q0. In Q0, I am having transition on input symbol E. Where will be my transition? Huh?
Ma'am, after start, like if we encounter B, it's on going back to Q0, right? The Q0 state.
Please repeat, ma.
Ma'am, after we start and we keep on getting B, we keep on going back to Q0 state. And if we
Hmm.
get an A, we move on to Q1. So what if we get
Hmm.
something else, like that is not in the language set or any other
There
character?
won't be any transition at all. So as you say, if I suppose I'm having this one, right? So here there is no input symbol at all, right? So it will be trapped. There will be no transition at all. Okay.
Okay, ma'am. So like it will stay in the Q0 state or it will not even start?
Which one, ma?
Like if we encounter C.
This
Yeah,
one. It will be
yeah.
as a Q naught itself. It will be in the Q naught itself.
Oh,
Because in Q naught, so here in Q naught I'll be coming across C, right? So for input symbol C, I'm not having any transition at all. So how it can proceed? So it will try. It will be stopped. Okay.
okay. Okay. Yes.
Okay. So here we can proceed with. So in Q naught, I'm coming across an input symbol A. Where will be my transition?
Q1.
Good. Q1. In Q1, I'm coming across B. Where should be my transition?
Q0.
Yes, very good. Are you clear with this? Are you clear with this? Should I repeat? So please make a note. What is the target? At the end, I should have two A's, right? So here in Q0, I am coming across A, and so I am moving on to Q1. As your friends say, if I come across a B, where I should do, I should move on to Q0 because only then. So let us see here. Okay, I'll be having a transition to Q0. So here again, what happens? I am in Q0. In Q0, I am coming across A. So again Q1. In Q1, I am coming across. Sorry, B. So I am moving on to Q0. In Q0, I am coming across A. So Q1 here. In Q1, I am coming across A. So I am moving on to Q2. Are you clear with this?
Yes.
Yes. Yes. Now, please see here. A, 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 B, A. Is it a valid string?
Yes.
Yes, good. Okay. So let us start with A. Okay, similar to that I have taken. Okay, so here I am in Q0. So what happens in Q0? I am coming across A, right? I am coming across A. So I'll be moving on to state Q1. Okay, so I'll be moving on to state Q1. In Q1, I am coming across A. Okay, in Q1. So please make a note. I have to proceed with the transition until my input string is over. Okay, until my input string is over. Okay. In addition to that, at the point my input string is over, I should be able to reach the final state. Okay. So in Q1, I am coming across a A. What happens? I will be reaching the final state Q2. So in Q2, I am coming across A. So what happens? I will be in the same state Q2. In Q2, I am coming across B. So where should be my transition? So if suppose, yes, if suppose I am getting the string, can the string be accepted by my automata, finite automata? Is it a valid string?
No.
No, no, right? Yes, good. So what should I do? On seeing an input, I hope one of your friend said now. So where should be my transition?
Q0.
That's good. I should have the transition to, sorry, have the transition to Q0. Right. So now I am in Q0. In Q0, I am coming across A. Q1. In Q1, I am coming across A. So reach Q2. Are you clear with this? Say so, Noma.
Yes.
Yes, good.
Yes, ma'am.
Good. Okay. Okay. So we have discussed now, right? Now try to design a finite automata. Okay, just so not this one, right? Try to design a finite automata. So please don't consider this one. Please don't consider this one. Input symbols are A and B, right? Input symbols are A and B. Try to design a finite automata for the language of strings ending in B. Just try it out. Please
Ma'am,
do try it out. Yes, no.
yes. In this case, so instead of A and B, which is the input set, if we get something else, it will again remain the same state, right? But
Yes, yes.
actually, it should terminate or something, right? The program should end, or when it gets an error.
The syntax error will be thrown. So at one point of time, if it does not proceed to reach the final state, it will be informed, and then compiler will inform you with regard to the syntax error.
Oh, but
Okay. Just here in this case, we are not discussing with regard to the just pattern matching we are dealing with.
oh,
And one more thing, it is going to be a transition diagram, right? So each and every one, so it is not mandatory that everyone should get the same transition diagram. So similar to the programming, that's it. So everyone will not be ending up with the same programming code, right? So based upon the logic followed, they will be coming up with different strategies. Okay, similarly, it is not mandatory that if 60 students are designing a finite automata, and similarly, if I am designing a finite automata, it is not mandatory that you will also get the same thing. You will also have to do the same thing. That's not the thing. So only thing is it should accept the given model. Given language. Accept the given language. That's it. Okay, hope you have tried that one. It is almost similar to the previous case where we will be having only where previous case we had A. Here we deal with B. That's it, right? So now what we are going to deal is design a finite automata for the a language of strings ending with B but not containing the substring A. Please make note over here. Not containing the substring A. So that is that's what I am repeatedly saying. You should be able to understand the language, right? So if you can understand the language, then very well you can proceed with designing the automata on your own. So here, yes. So the very minimal possible string is B, ending with B, right? A, B is possible. A, B, not possible. It is not a valid string, though it is ending with B and having a substring A, right? Do you know substring, right? You are all, so you know substring, right? So that is whether it is from the front prefix or suffix deleted, and we having a part A, continuous character A. Okay, so here AAB not possible, then AB, AAB not possible, likewise it goes on. So I should not have AA. That's it. Okay, so these are the possible strings. AB is possible, AB is possible, ABB is possible, likewise it goes on. Right? So what should I do? So first I have to design the finite automata to accept B. So I design the finite automata. Right? If I see a B, I should reach the final state, right? I should reach the final state. What happens if I see a A? Where should be my transition? Hmm?
Back.
It's not clear for me. Can you please repeat?
We have to come back.
No. What I'm asking is, I am in state Q0. In Q0, I'm coming across A. Where should be my transition from Q0? Should I be in Q0 or should I be in Q1 or should I go to a new state?
Q0.
Okay, let us consider I am in Q0. Yes, please wait. So what happens if I do like this? This will be accepted, right? This will be accepted, which does not belong to that language at all. This string does not belong to that language at all. So what should I do? As you mentioned, I should move on to another state. On seeing a A, I have to move on to another state. Let me call this as Q2. Okay, is that clear? So here I am in state Q0. In Q0, I am coming across A. Where is my transition? I am moving on to Q2. In Q2, I am coming across B. Where should be my transition?
Q1 terminate.
Yes, good. I should move on to Q1. Right? So my finite automata will accept this. And then what about ABB? Yes. I am in state Q0. In Q0, I am coming across A. Where is my transition? I am moving on to Q2. In Q2, I am coming across B. I am having transition to Q1. Where should be my transition? In Q1, I am coming across B. Where should be my transition?
Q1.
Q again.
Yes, good. Q1. Right. In Q1, if I come across A, so okay, please wait. Is this a valid string?
No, ma'am. It's not any.
No, it is not valid, but this is valid, right? So okay, right? So here I am in state Q1. So whatever may be the case, okay, whether here or here, okay. So I am in state Q1. In Q1, I am coming from. So what is this? I think A, right? So what is this? B. Okay. So in Q1, I am coming across A. Where should be my transition?
Q2.
Yes. If I come across A, I can have the transition to Q. Q2, right? Okay, so again, if I see a B, I'll be moving on to Q1, right? I'll be moving on. So here you can see in Q2, so here I'm having a transition to Q2. In Q2, I come across B, so I'm moving on to Q1, right? So this holds good if this condition is, if this given string is this one. If suppose this is a string, right? Please make a note over here. In Q1, I am coming across A. So where will be my transition? I will be having a transition to Q2. In Q2, I am coming across A. Where should be my transition? Should it? Huh?
Use again here.
Please repeat Q2 again.
New state.
Yes. Good. New state, which is called as the trap state here. Which is called as the trap state. After moving on to this state, I will be not in a position to reach the final state at all. So please make a note. After I come across this one, I should not be able to reach the final state. Okay, I'll be in the trap state. So here I'll be in this state, whatever may be A's and B's come. Okay, I'll not be in a position to reach the final state at all. So here you can see I have come across the AA, which doesn't belong to this particular language, so I should not be able to reach the final state. So this state, what we have introduced here, is called as the trap state, right? This is called as the trap state. After reaching this state, I'll be not in a position to reach the final state. Is that clear for you? Are you clear with this?
Yes.
Yes. Yes, it's good. Almost a time. Okay, please make a note over here. Try to design a finite automata for the language of string containing substring ABB AAB.
Ma'am, you're not present.
I have chat. I have sent a chat message. I have sent a chat message. Please do see it. ABB AAB. Try to design a finite automata for that. We can discuss the same in the next class. I have downloaded that. Okay, sorry, it's almost late. Okay, you can leave, ma. It's almost late.